Tywin's war strategy is today's problem. Difficulty is easy. Concerns me a little bit that the accuracy is that low, but you are given an array of size n, where array at I represents the number of soldiers in the ith troop. You are also given an integer k. Troop is considered lucky if its number of soldiers is a multiple of k. Find the minimum total number of soldiers to add across all troops so that at least, okay, that looks like a ceiling, at least n over 2, ceiling of n over 2, troops become lucky. All right. Let's do some examples here. Well, actually, before we do the example, let's take a look at this. No empty arrays. Okay. Array size will be between 1 and 10 to the 5th. That is 100,000. K also between 1 and 100,000. And the troop count, or the soldier count for each troop, would be between 1 and 100,000. Expected complexities. Okay, sorting is good. Expected complexities. Why is that not opening? Oh, I see, because I've got it on a pen here. N log n. Good. That's what we want, because we want to sort it. All right. Let's see. What are we going to do here? We're going to have an array list called diff, which would be the number of soldiers, if any, that we need to add to troops to make them lucky. There's a computation that we're going to do here. For every number in the array, if num mod k equals 0, that means it's already lucky, and so we'll just put a 0 in the list. If num mod k is not 0, we can figure out how many troops do we need to add by computing k minus num mod k. How would that work? Well, like, what is, let's do it with this one. The 2 is too easy. Let's do k equals 4. What is 3 mod 4? Well, it's 3. And then if we took 4 minus 3, we would get 1. And 1 is the number that we would need to add to make that lucky. What about 5? 5 mod 4 is 1. 4 minus 1 is 3, so we would need to add 3 soldiers to this troop, and so on. So let's go ahead and do that. So we're looking at this one. K is 2, so we need troops to be divisible by 2. So we would need to add 1 there, 0 here, 1 here, 0 here, and 1 here. Now, we can sort that, and if we sort it in ascending order, it'll be 0, 0, 1, 1, 1. We'll run a loop from 0 to n plus 1 divided by 2 as integer division. We want to make sure that we get the ceiling, and so n plus 1 divided by 2. In this case, n plus 1, what is n? N is 5. 5 plus 1 is 6, divided by 2 is 3. So we need 3 lucky troops. The first 3 numbers here sorted would be 0, 0, and one of these 1s, but the total would be 1. Okay? Let's try the second one. This needs to be divisible by 4. So in this case, we need to add 1, we need to add 3, we need to add 2, we need to add 1, we need to add 3, and we need to add 2. Now, if that was sorted, it would be 1, 1, 2, 2, 3, 3. And how many lucky troops do we need? That's 6. 6 divided by 2 is 3. So we would need 3. 1, 1, and 2 for an output of 4. All right. Anything else? No, that's it. We're just going to go through all the troops. How many soldiers do we need to add, if any, sort them in ascending order, and pick the number that we need, starting with the lowest number, and that should give us the minimum total number of soldiers to add. All right, let's get rid of the annotations and submit. All right. That was pretty easy. I don't have anything else to say about it, but go ahead and like the video and subscribe to the channel. I'll send you every weekday a problem of the day. You can try and solve it. If you need some hints, you can watch the video. All right, see you next time.